Okay, today we are going to talk specifically about arithmetic and geometric sequences. Some of you may first of all say, why are you saying arithmetic? Well, it looks like arithmetic. And of course they are spelled the same way, but it depends on whether you're using it as an adjective or as a noun. As an adjective, it is arithmetic. As a noun, it is arithmetic. So we are talking about arithmetic because we are describing the types of sequences. And arithmetic means that we are adding or subtracting to get to the next term. That is the key thing here, adding or subtracting. Whatever we're adding or subtracting, we call the common difference, and in the formulas we use the letter D for that. And again, that's what we are adding or subtracting. And then we have this formula that will help us get any of the terms that we want. We need to know the first term, what number term we want, and the difference to be able to get whatever term that is that we're looking for. But this formula can also be used to find any of the parts that are missing as long as you have enough given information. Alright, so let's move down and do some examples. The first one is we have the first term of an arithmetic sequence is 4 and the common difference is 2. So we have a sub 1 equals 4 and d equals 2. They want us to find the ninth term, so n would be 9 for what we're looking for. Then we just plug it into our formula. A sub 9 would equal a sub 1, which is 4, plus n minus 1, so 9 minus 1 times d, which is 2. And if you calculate that, you should get 20 as that ninth term. Alright. For the second one, we want to find the 15th term of the arithmetic sequence. 1, 1.25, 1.5, 1.75, so kind of like money, thinking like that. So we want the 15th term, which would be n is 15. We know the first term is 1, so that's a sub 1. And our d, if you figure out what we're adding 0.25 each time. So 0.25 is our d. If I plug that into my formula, I have a sub 15 equals 1.00 plus n minus 1, so 15 minus 1, times d, which is 0.25. And again, all you have to do is plug that straight into your calculator and you get 4.50. Alright, third example. If a sub 3 is 10 and a sub 6 is 19, find a sub 1 and d. This is a case where it has a little bit more work and you don't have a sub 1, you don't have d, you don't have two things. So you need two equations and you need to do substitution. So I'm going to do the first one. I'm going to set up what I know in the equation. So a sub 3 would be 10, so 10 would equal a sub 1, which we don't know, plus n minus 1, in this case our n is 3. And our d we don't know. I can simplify this a little bit and say 10 equals a sub 1 plus 2d, which is a little nicer to work with. For the second one, a sub 6 is 19, so 19 is going to equal a sub 1 plus n minus 1, so our n here is 6, 6 minus 1d, and again I'm going to kind of simplify that, a sub 1 plus 5d. Alright. At that point, I want to do substitution, and so I am actually going to solve this first equation for a sub 1 and plug it into the second equation. So I need to subtract the 2d, so 10 minus 2d equals a sub 1, and I'm going to plug that in over here. So I'm going to say 19 equals, instead of a sub 1, plug in the 10 minus 2d, and then I still have the plus 5d on the end. So 19 is going to equal 10 plus 3d when I combine like terms. Subtract 10, get 9 equals 3d, and then divide by 3 and get d to be 3. So now I know d, that's one of my answers. I just have to plug it back in here or here to get my a sub 1. So I'm going to plug it back into this one. So 10 minus 2 times 3, now that I know that's d, equals a sub 1. That's 10 minus 6, which is 4. So a sub 1 should be 4 and d should be 3. Okay, for my fourth example, it says insert 3 arithmetic means between 6 and 26. That means I have a sequence that's 6, and then 3 somethings that I don't know, and then 26. So let's think about what I know. I know that the first term is 6, so I know a sub 1 is 6. And I know that the 1, 2, 3, 4, 5th term is 26, so a sub 5 is 26. I don't know my d. That is the question. So I'm going to use that formula again. I know a sub 5 is 26, so 26 is going to equal a sub 1 plus n minus 1. The n that I'm using is 5 because I'm using a sub 5 over here. So 5 minus 1d. So 26 is going to equal 6 plus 4d. Subtract the 6. Divide by 4. Our d is 5. That means I'm adding 5 to get to each of the next terms. So 6 plus 5 is 11. 11 plus 5 is 16. 16 plus 5 is 21. Okay, now we're going to move on and talk about geometric sequences. Geometric sequences are when you're multiplying to get the next term. And then some people say, well, what about dividing? Dividing is actually just multiplying by a fraction. So we can lump it all into geometric because it's all actually multiplying. When you are multiplying, that common ratio r is what you're multiplying by. If you can't figure out what they're multiplying by, then take the second term and put it over the first term and reduce, and that should give you your r. Your formula for this one that we're going to use is a sub n equals a sub 1 times r to the n minus 1. So again, we'll need to know a sub 1, the first term, r, and then the place in the formula that we're trying to look for an answer. So for example 5, we've got the 8th term of the geometric sequence 2, negative 6, 18, negative 54. So I'm going to find my r. My r will be my second term over my first term. So in this case, negative 3. And you can check it. 2 times negative 3 is negative 6. Negative 6 times negative 3 is 18. 18 times negative 3 is negative 54. So that does make sense as my r. I also know my a sub 1 is 2 because it's the first term in the sequence. So if I want the 8th term, I'm finding a sub 8. So I'm plugging into my geometric formula. So a sub 1 is 2 times r, which is negative 3. I'm going to put that in parentheses so I don't forget the negative, to the n minus 1. So 8 minus 1. So I really have 2 times negative 3 to the 7th. And it's important again to keep that negative in parentheses. Now, some people mess up because they multiply the 2 and the negative 3 first. But we have to follow the order of operations, which means exponents comes before multiplication. So you need to do the negative 3 to the 7th first. So that would be 2 times negative 2187. And then do your multiplication, which will be negative 4,374. Our last example says to find 3 geometric means between 3 and 768. So similar to that last problem, I have 3 blanks between that first number that we know and the 768 that we know. That tells me my a sub 1 is 3. 1, 2, 3, 4, 5. This is in the 5th spot, so a sub 5 is 768. I don't know my r. If I did, I could easily fill these blanks in, so I need to find it. If I use my other formula, a sub 5 is 768, a sub 1 is 3, r is what I don't know, and my n that I'm using is 5 because of what we know. So 5 minus 1 as the exponent. So 768 is going to equal 3 times r to the 4th. I'm going to divide by 3 and get 256. And then I'm going to take the 4th root of 256. If you need help with that, let me know. I can show you how to do that on your calculator. You should be getting 4. That means I'm multiplying by 4. So 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. And 192 times 4 is 768. So that fills in my blanks. That concludes this set of notes.